Hello, SAT people. Welcome to practice test 2. We're going to go over some of the answers together. And this is the no calculator portion of the test. We are jumping right in to number 7. This is low-key one of my favorite problems. This is such a typical, such a basic. It's not that basic because it's kind of hard, but it's a total typical SAT question. Okay, first of all, they give you a equation that looks confusing. They give you some information here. A plus B is 2. What am I going to do with that? And they want me to find the value of A minus B. When in doubt, just start doing some math. I am noticing here that I'm working with exponents, so I'm going to think back to Algebra 1 and my exponent properties. Something I always say when I teach exponent properties is fraction, subtraction. If I have the same base raised to an exponent in a fraction, I can subtract my exponents. So this is going to be, technically we would get this. X to the a squared minus b squared equals x to the 16th. Well, at this point, the left side and the right side, this is now getting into Algebra 2, have the same base, so now I can set my exponents equal to each other. Okay, so I get a squared minus b squared equals 16. All right, so now I'm thinking, what can I do with that? Well, look at the problem. I have something with an a plus b, and I'm looking for an a minus b. This a squared minus b squared is the difference of squares, so I can actually factor it to a plus b, a minus b. Now things are starting to look familiar. I'm getting warmer. But I know that a plus b is equivalent to the number 2. So let's replace a plus b with the number 2. Now, don't start to distribute. That's actually not necessary. I am looking for the value of a minus b. So let's get that quantity alone by dividing over the 2. If I divide over the 2, I get a minus b equals 8. I'm done. Answer is A, 8. Beautiful. I love that one. But it's tricky. So hopefully you learn from this. And we are now going to move on. Oh, you know what? I jumped to 7. Let's backtrack. I meant to do 6 first. My bad. 6 is a quick problem, and I already drew some things out for you. It gives me, without those dashed lines, it gives me that graph of 2 lines, and it's in an XY plane. We know that the lines are parallel. Okay, so remember, parallel lines have the same slope. So what I did with this first line was I counted the slope. The slope goes up 2 and then right 5. So the slope is 2 over 5. Okay, now if I do that pattern again with the next line, knowing that they're parallel means they have the same slope. So given that information from this first point, 0, negative 4, if I go up 2 and right 5, okay, I'm going to be at the point 5, comma, negative 2, right? Because I went up 2 from negative 4, and I also went right 5 from 0. Now, if I continue that pattern, I go up 2 again. Now I'm going to be on the x-axis, and I go another 5 over. I'm going to be at 10, 0, which is the answer. The value of p in that point is going to be 10. So we did 7, and then we went back to 6, but now let's keep going on, going over our next problem, which is number 10. So I took the liberty of drawing some things out for us to make this go a little bit quicker. But this says, which of the following equations has a graph in the xy plane for which y is always greater than or equal to negative 1? So there's different ways to do this, okay? Notice that I wrote some things here. Knowing about transformations, you start learning about transformations in Algebra 1, but really get into it in Algebra 2, all right? I know that function letter A is an absolute value function that's been moved down 2 because of this minus 2 at the end. Same story for B, except it's quadratic instead of an absolute value, but it moves down 2. Letter C is different. The minus 2 is in the parentheses, so this actually is a parabola that's been moved right 2. And then the last one is a cubic function that's been moved down 2. So notice that 3 out of the 4 moved down 2. My answer is probably going to be the one that's different, right? The only one that moved right instead of down, but let me show you why. So if you look at example A, or answer choice A, there's an absolute value that's been moved down 2. I drew the dashed purple line at y equals negative 1. Notice that the graph goes below negative 1. So that means that A cannot be an answer. Okay, I'm looking for the y values only greater than or equal to -1. And answer choice B, the function moved down to, the purple line's at -1, this function goes below -1. And answer choice C, the function moved to the right. And it's a parabola. It's never going to go below that x-axis, which means it will never go below -1. So the answer is going to be C. And then just to prove my point, answer choice D is a cubic that's been moved down to. That is going to drop below -1. So the answer is definitely C. Okay, we're going to go up to number 11. Love number 11. This is a classic Algebra 2 question. It gives me an expression, 3 minus 5i over 8 plus 2i, and it says what's equivalent to it. This is a rationalizing problem. We have to rationalize. We're not allowed to have an I in the denominator because technically an I is a square root. So what we do is we rationalize by multiplying by the conjugate. This is something you should have learned in Algebra 2. The conjugate is going to be where you just take the denominator and change the operator. Operator is plus in the original, so I changed it to a minus. All right, and I'm actually, this is, a little tedious. I am going to have to FOIL both the top and the bottom. Okay, so let's do the bottom first. If I FOIL that, I get a 64 plus 16i minus 16i, and then minus 4i squared. Okay, so a couple things here. The 16i's cancel. An I squared is equal to -1. So I usually just cross it off and change the sign. Technically, it was a -4 times a -1, which is a +4. So 64 plus 4, okay, is 68. And then if I factor or FOIL the top, let's see, this one's going to be a little bit more complicated, right? So I get a 24. Let's go minus 6i, and then minus 40i, plus 10i squared. Okay, a couple things to do. The I squared is -1, so that's going to change to a -10. So I get a 14 minus 46i over 68. And so if I divide everything by 2, I get 7 minus 23i all over 34. And that is equivalent. Careful here, careful here. Notice that there's a minus. So it's answer choice C. And I said be careful because I think sometimes, I actually was about to circle answer choice D, and sometimes we just get really like, oh, I got the answer, and then answer, one that looks really similar. So just double and triple check that you have the right one. All right, so that was answer choice C. Some fun algebra there. All right, moving on to number 12. So for number 12, it gives me an original formula. A website uses this formula to calculate a seller's rating, R, based on the number of favorable reviews, F, and unfavorable reviews, N. It says, which of the following expresses the number of favorable reviews in terms of the other variables? In other words, solve for F. Another classic Algebra 2 problem because there's two F's. So what do? Here's how we're going to do this. We're going to start by multiplying over the n plus f to the other side. So it looks like this. R times n plus f equals f. Okay, so now I am going to distribute the r. I have to do that because there's two f's. So this is going to be the only way I can isolate f, is by distributing and then gathering the f's together. Okay, so I want the f's on the same side. Okay, so I'm going to take this RF and I'm going to subtract it over. So I have RN equals F minus RF. So now looking at the right side, what I can do is factor out the F. And then I have a 1 minus R left over. And on the other side, I still have that RN. And now I'm trying to isolate F. So I'm going to divide over the quantity of 1 minus R. Here's my final answer. Rn over 1 minus R is equal to F. And That is answer choice B. Amazing. I like that one too. Again, SAT, they're going to try to throw you off by giving you a complicated looking equation. Just, you guys know what to do. All right, we got a couple more here. I'm actually going to skip number 13 and go over 14 and 15 with you guys. So, okay, this next problem says it's a radioactive substance that's decaying, okay, that gives you the rate of 13%. If the initial amount is 325, then which of the following functions can model this? Okay, so that was my chair moving. Here's the deal. I wrote down two equations here. The one that I want is the blue one because we're talking about decay. This is a general formula. It's good to know it for the SAT. The A stands for the initial amount, and if I'm decaying, then the formula is 1 minus the rate, raised to the time, okay? Now, the one in red is if it was growth. So if we were not decaying and the substance was growing, then I would use this equation, okay? But it's not. So another thing to think about is that the A stands for the initial amount. So the number in front of the parentheses should be the initial amount, which was 325, which means I can eliminate answer choices C and D because the numbers in front of the parentheses are not 325. All right, now the rate is 1 minus R, so it's not going to be just 0.13. It's going to be 1 minus, so it's 325 times 1 minus 0.13. to the T power, and that's going to be answer choice A. So this problem was really just knowing that decay formula. It's a good one to know. So moving on to number 15, I thought this one was a little bit hard. The expression 5x minus 2 over x plus 3 is equivalent to which of the following? And I thought it was hard because answer choices A and B threw me off when I was first looking at this. But here's the deal. Those are numerical answers, and we just don't know enough information to say if those numerical answers are equivalent to the expression because these are unknown. Maybe this is true if x equals a certain number, or if x equals 1, or if x equals a certain number, then maybe A or B could be true. But we don't know what x equals, so we just don't know enough information to say that it's answer choice A or B. So let's look at C and D. What I would do here is take these answer choices and get a common denominator and see if when we combine everything up, we get back to the original problem. So for both of these, they start with a 5 and both have a denominator of x plus 3. So to get the common denominator, this is algebra 2. I'm just going to multiply the 5 by x plus 3, x minus 3. I'm sorry, x plus 3 over x plus 3. And then I'll have a common denominator, right? So simplifying this first one, answer choice C, I get a 5x plus 15 and then minus 2 all over x plus 3. 15 minus 2 is 13, so it's not this one. But I'm going to do the same thing here. And I get a minus 17 over x plus 3. So now I have the 5x, I'm just distributing, plus 15 minus 17 all over x plus 3, which is 5x minus 2 all over x plus 3. So that is the original problem, so it's answer choice D. Okay, last two. These are the grid-in questions, the short answer. Love the first one. Number 17 is the first one I'm going to go over. Basically, it's saying, hey, here's an expression, and if this is equivalent to, the standard form of a quadratic, give me the value of b. So really all you have to do is just distribute and combine like terms. So if I distribute the 2x here, I get 6x squared plus 10x plus 9x plus 15. So I get 6x squared plus 19x plus 15. So the 6 is the a value. And the 19 is my answer. That's the b value. If it asked for the c value, the answer would have been 15, but the answer is 19. Okay, and last but certainly not least, number 18. It gives me, I highlighted the parallel segments in orange. Okay, so because these are parallel, I know things like, oh, the alternate interior angles are congruent. I also know that I have vertical angles here. Right there, angle is enough for me to know that these two triangles are similar. And so there is, the sides are proportionate. So if this longer side is 10 and the shorter side is half of that, then if this side is 8, the shorter side is going to be half of that. So this CB is 4, but it's not asking for CB, it's asking for CE, which I highlighted in blue. So I need to add together 4 plus 8, which is 12. And that's the answer. 12 units long. All right, guys, so that is going over the no calculator portion of this test. And I will go over the calculator portion with you too. Hope this helps.